Hello, welcome. My name is Taylor Brown. I'm the lead program manager in charge of all of our Windows container technology focused on servers. One thing I'm trying new for this session and hopefully future ones, I've actually tweeted out a link to the slides. So if you're like me and you kind of like to follow along yourself, the slides are live. You can go pull them from docs.microsoft.com or docs.com through the link on my Twitter feed. If you find that useful, let me know. That'll encourage me to keep doing it. Otherwise, things happen. Joined today by?
Hi, I'm Patrick Lang. I'm a program manager working on Windows containers as well. And I'll be doing a number of demos for you today, and we've got more sessions coming up on Thursday as well.
Yeah, so. Actually, that's a great segue. So why are we here today? What are we doing in this room? Well, hopefully, like me, you think containers are kind of cool. You heard about them in the keynote. They look like they're a pretty neat technology. So this session is all about kind of the what, why, and how of containers, right? Let's understand how they work, what they're useful for, how they fit into the Windows architecture. Then on Thursday, we've got a session that's going to be given by a gentleman named Mike Coleman from Docker. And that is going to go over kind of the overview of Docker. What have we learned from using Docker in Linux? How do we manage things with it? What are some of the use cases and kind of the nuts and bolts of that part of it? And then following that session, a joint session from Tycho and then us, Patrick's going to do most of this session, that's really going to talk about how do we take that first step? How do we get that first app moved over to a container? What are some good candidates for it? And how do we get started? And then kind of closing the week out on Friday, we've got a talk by the Visual Studio team that's going to talk about some of the tooling that they're building to make it easier, right? So the goal of all this is that when you get back to your offices on Monday, you can take that first app and make it a container, right? You can take that first step and along this journey and get yourself into containers. So with that, we've talked about this, you've heard about it. The cloud really has changed the expectations on what it is to have an application, right? When we think about applications to now, they have to be available all the time. If you try to go to Amazon and Amazon is down, you find an alternative. You go to Walmart, you go to some other site, and the chances are you may never come back to that first site again, right? If they give you a good experience, you're done. The next big part of it is scale. We have to be able to scale rapidly. We have to be able to scale our apps both up and down at a moment's notice. And then the last piece of this is agility, right? If we can't take advantage of the opportunities that are in front of us when they're opportunities, then we will fail compared to our competition. Our competition will take that opportunity, and they will capitalize on it instead of us, right? So these have become some of the expectations that we have for running applications and building applications in this cloud world. Whether or not they're actually hosted in the cloud or not, this is what people have come to expect from their applications now. So that lends the question, why containers? Well, because it turns out that transforming an existing app into a cloud app is really, really hard. And building a hybrid cloud app is actually really, really hard. But containers make it a lot easier. Right? And why is that, or how do they make that process easier? Well, there's a couple key things that the containers do for us from an application or an infrastructure standpoint. One, they drive consistency, and two, they have an efficiency quotient to them. And when we look at what those actually give us, this is the important part of it, from consistency, we gain the ability to do really rapid deployments. Why? Because things work the same way every time. They work the same way in an office as they do in the lab, same way in the lab as they do in production. That drives a faster iteration cycle, right? If I know something's going to work the same way, and I can say, you know what, like I've built it, it works on my machine, I can plug it into a process, I can push it out to release, and it's going to work the same way, I can turn that crank a lot faster. I have a high level of reproducibility. If it breaks there, it's going to break here. If it doesn't break, it's not going to break there. I can run it on any cloud, because it's going to run the same way. I don't have to worry about, well, I have it working here, I put it into our data center, and it's working fine there, but if I go try to move it into Azure or Amazon or Google or wherever, is it going to work? Because it works the same way. It's consistent. And some of you caught Jeffrey Snover at the very end of the last session talking about immutability, building immutable infrastructure. Containers are, in definition, immutable infrastructure. The efficiency side of it drives a couple other key things. Because containers are efficient, they're efficient at resources, we can do better service separation. It's pretty hard to justify running 20 VMs so you can split your application into 20 different services if each one of those VMs is using 4 or 8 gigs of RAM and the service that's running on is using 200 meg. Right? That's a pretty hard thing to justify. But when the service is using 200 meg and that means your container is using 250 meg, yeah, I can justify that. And that allows me to have a much higher degree of agility. We get a high availability out of that. Why? Because we can run more instances of it. I can have 2 front ends. I can have 8 front ends running at the same time because I'm not having to worry about some of the overhead. Drives more scalability. I can scale out faster. I can scale out to different environments because I can start up a container, and we'll talk about this in a few slides. I can start up a container in a second. So I can scale at real time. Right? I can also test at scale. It's kind of hard to test a 3, 4, 5, 6-tier application on a laptop if you're using VMs, and each one of those VMs takes a gig or 2 of RAM. It's pretty easy to do it when you're using containers, and they only take a couple hundred meg. So I can actually test the same way I'm going to run in production. And then, of course, a key one for a lot of us is reduce costs. I'm not having to pay for as much infrastructure because I'm using it more efficiently, right? So these are some of the ways that containers make it easier. We haven't answered the real elephant in the room, though. What is a container? So there's a lot of different ways we can look at this, but one of the ways that I think is really, really valuable is to kind of take a step back. So not that long ago, some of you are younger than me, so you won't remember these times, but we bought a compact server, and it showed up in a box, and we unboxed it, and we threw it in a rack, and we popped a CD in it, and we installed Server 2000 or Server 2003 on it. And then we merely went away and installed Exchange or SQL or whatever the application was. And that server sat there for 3 or 4 years, and we'd patch it, and we put a name on the front of it. It had some cartoon name that we dubbed it. And that was our world. But as that hardware got faster, and we wanted to take advantage of the additional resources, we invented virtualization. So we started cramming a bunch of VMs on these servers. That's why we started virtualization. We started it to take advantage of the CPU we already paid for. What that actually enabled, though, is it enabled us to move those virtual machines around. We got some portability out of it. Because they ran the same way, we could now move them into the cloud. That was the birth of infrastructure as a service, the birth of the cloud that we have now. When we contrast that with containers, or we look at that under that same lens, containers are a way of doing operating system virtualization. What we're really doing is we're taking the operating system, we're carving it up into multiple pieces so we can run a piece of our application inside of that operating system without other pieces or other applications in there knowing about it. Just like we do with VMs. Just like we take a virtual machine and we put it on a machine, we carve up that machine, they're unaware of each other. Containers do much the same thing. Now, the real power of it is that portability. Just like virtual machines, it gives us this ability to take that virtual hard disk, in the case of a container, it's an image, and move it somewhere else and have it run the same way. That's the real power, not the ability to carve it up. That's powerful alone, but the real power is the portability of it. And so in Windows Server 2016, we're really excited to be debuting 2 container technologies. The first is what we call a Windows Server container. This builds on the traditional model of containerization. We have a shared kernel. We've taught that kernel how to virtualize, how to lie to the applications running inside of the container, and make them feel like they're running all by themselves, like they're the only child in the family. And at the same time, we built what we call a Hyper-V container. A Hyper-V container bundles and uses our virtualization technology and our hypervisor to run that same container instance, but inside of an isolated environment. And we'll talk about how that actually works here in just a moment. So how do containers work? First and foremost, it's important to understand that containers themselves are an operating system construct. They live in the operating system. This is true in Linux, this is true in Windows, this is true in Solaris, this is true in all of the real container runtimes. The operating system is ultimately what the container runtime lives in. On top of that, we have tool sets. So this is where the Docker engine comes in. The Docker engine talks to the operating system primitives. In Linux, it talks to C groups and namespace providers. In Windows, we built a layer that we call the host compute service. It talks to that, right? It's the one who understands when you say, start me up a container, how to translate that down to me to say, build me a namespace and do this and do that, and call the right system APIs in order to facilitate that. On top of that, dangling L in PowerShell, Jeffrey would be so disappointed. We have different tool sets that talk to the Docker engine. So the Docker client, Docker PowerShell, Compose, Registry, Swarm. All of these tools kind of talk to that engine underneath. And then even on top of that, we have things like the Docker Universal Control Plane, other orchestration engines that can talk down through this stack, right? So I'm an operating system guy. I want to dive into the operating system. How did we make the operating system work? This should look fairly familiar to most people who've looked at Windows architecture. We have a user mode, and we have kernel mode. Kernel mode's got a bunch of drivers in it. User mode has a bunch of processes in it. If you look at any Windows machine, you're going to find a bunch of common processes. We call them the system processes. Local security authority, things like that. And then we've got our container management, the host compute service, we just talked about a little bit, and then the Docker engine, more importantly. When we start up a container, what we're actually doing, we're using the same kernel. We start up this isolated environment. Really what it looks like is a new user mode. It looks like a new instance of user mode. And then we kick off a new instance of those system processes, the local security authority, WMI providers, all of those core system processes run inside of that container as well. And then, of course, we actually run the application processes in there. Why do we run the system processes inside that container? So that the container has its own copy of them, so it's got its own view on it. Because what does the security authority have? It knows about user accounts. I don't want my container to know about my host user accounts. I want my container to know about its accounts, any account that it was to create, any account it was to manage. I don't want it to know about the host WMI provider and what drives it has on it. I want it to know about the virtualized view I gave it, so I run my own copy of them. When we look at a Hyper-V container, we're now using the hypervisor. And as I said before, it's got its own copy of the kernel. It can actually run a different kernel than the host even. Then we start up a Windows Server container inside of that. We're doing all of that inside of a special virtual machine. We built a brand new type of virtual machine whose job is solely to run a container. The reason we did that is so that we could take a bunch of shortcuts. We do something cool. We clone these virtual machines. Before we actually start that container inside, we make a copy in memory of it, so every time we start another one, it's that fast. We can just start it right up, right? We don't boot from a virtual hard disk. We boot from an SMB redirected from the host. We use a different memory management policy, so we can share memory across them, right? That's why we do all of these Hyper-V container techniques. And what that gets us is some pretty cool stuff. So this is actually starting Node.js inside of a container, a web listener doing some real work. It's accepting a basic web request. We can start that up in a Windows Server container in under 1 second. It was like 998 milliseconds, so I rounded up for the sake of clarity. We can start a Hyper-V container in 3.3 seconds, completely up, running with Node.js. If we look at a virtual machine, 5 seconds if we're fast and we've already gone through sysprep the first time and all of that. If it's got to go through sysprep and everything else, we're over a minute. So in real-world terms, starting up a virtual machine to do some new work is about a minute and a half to do a server core. We can do it in 1 second. If we go look at NanoServer, optimized, NanoServer can start in under 600 milliseconds. Last year when I stood on stage, it took us like 10 seconds to start a Windows Server container. Got that down to 1 second. We've got Nano down to 600 milliseconds. If I start up NanoServer inside of a Hyper-V container, I can do it in 1.7 seconds. Again, a virtual machine takes about 3 seconds to start. Let's talk about density. Same test, Windows Server container, 150 meg for the first one, and then each additional one's only 75. Why? Because we're sharing all of that memory. We're sharing all of those common processes again. For a Hyper-V container, the first one, it's a little bigger. It's about 500 meg, because we've got to start up that virtualized environment. But then each additional one's only 280 meg, because again, we're sharing a lot of that common memory across the containers. For NanoServer, the first container is only 120 meg. The additional ones are still about 75. Why? because the memory sharing on the server core one's actually pretty darn good. And so that's basically the infrastructure overhead. And then a Hyper-V container, 340 meg, so quite a big savings, and then 150 meg for each additional one. Right? So we talk about efficiency. Compared to a virtual machines, usually the smallest one's about 2 gig, most environments. Quite a bit of savings here. So how do I actually go about creating a container? Well, containers are very intent-based. You don't say, create. You can, there's a way to do that. But really what you say is, run. I want you to start. And that does the process of both creation and startup as one sequence. And we can do a bunch of things when we start a container. We can give it a name. We can give it interactive or service-based. We can give it network configuration. We can give it all sorts of stuff. We'll talk about those a little bit more. But to really see this, I'm going to turn it over to Patrick to actually give us a demo of starting a container.
All right, thank you, Taylor. All right, so give us a few seconds to switch over. All right, we're here. So right now I have a Windows 10 laptop that is running the anniversary update. And so the first thing I'm going to do is go ahead and do Docker images. And what this does is it's looking at the container images that are already on my machine. But the one I actually am looking for right here is this Microsoft Nano Server image. So the first time I run this, it would automatically be downloaded and run. But since I already have it on my machine, to speed things up, I'll just go ahead and run it. And I'll launch a PowerShell in there. So behind the scenes, this is bringing up that really lightweight VM quickly and getting it ready to clone it. And then we see, and by the time I finish that sentence, I've already got this up and running. So that's a Nano Server instance running in a container on top of a Windows 10 host. And if I go in here and look at the host name, I see that the container has a host name that's different from the host. My host name happens to be Roaster. I roast coffee, so that's what my computer's called. But let me go ahead and start up another container real quick. Docker run IT.
While he's doing that, it's important to just keep in mind that first startup time and the one you're going to see now, we're starting up a VM, then we're starting up the container inside of that.
Yeah.
Right? We're actually cloning the VM and then starting up a container inside of it.
Okay, so the second one, fingers crossed, should start faster. Okay, so now I've got 2 containers running. And if I look at the host name of the second container, we can see that they're both different from each other. And then if I can go and look at the file system, each one is independent. So if I go ahead and do, go ahead and create an extra file here, hello.txt. We see that it's persisted on that container. If I go look at the container on the right, I don't have the file there, but it is there on the left. So each one has its own independent file system. And then if I run ipconfig on each one, we see that they each have separate IP addresses. This one is 101, that one is 70. And so next I'm going to go ahead and shut down one of those containers. And if I want to look at the containers that are still running on the system, I can run docker ps, and of course I can see that that other container is still running. But to show you the immutability, I'm going to go ahead and launch another container using the exact same command line I did before. But what's happening right now is it's coming up with its own separate scratch space. So if I run hostname again, we see I've got yet another unique host name. And if I look at the files on there, it started from that clean state. So the changes I made in this container that's running over on the left are only persisted for that container session. So that's the basics of being able to start up a container from a read-only state very, very quickly, and then each one has its own isolated runtime.
All right. So that was a quick look at kind of creating a container. Now, when he started that, he started it from Microsoft/NanoServer. What is Microsoft/NanoServer? Well, it's a container image. What is a container image? A container image is really constructed of kind of 2 pieces, a set of contents or payload, and in the case of Windows, that's registry, and then files and folders, and some metadata. The metadata describes what it is. What's the name of it? Who created it? When was it created? What command should it execute when it first starts up? What dependencies does it have? Right? Ultimately, this is what a container image is. But when we think about it, it's really what we think about as a starting point. So all containers must start from something. They start from a base image. We have two base images. We have Nano Server and Server Core. Right? So ultimately, if you want to start from the very beginning of time, you can start from Nano Server and Server Core. Right? But what's more interesting is to start from a top level. Now, I guess I had some build-outs here. A container image. It's analogous to a VHD and a config created by running a container and then capturing the effects. All right, so we've got our base OS image. What we layer on top of that typically is an application framework. So that could be something like IIS, or Node.js, or .NET Core, or anything we really want. And then on top of that, we layer on applications. Now this picture could be 10 layers deep, it could be 2 layers deep, it could be 100 layers deep. It doesn't really matter. But for most applications, this is typically a pattern you see. So we start with our base, we layer on an application framework, and then we layer an app on top of that. So now if I'm a developer, I care about the application framework. I go and pull the application framework. I don't care what base image it's running on. I care about the application framework. If I'm deploying something into production, I don't care about the application framework. I care about the app. Right? We now get to talk about the artifacts that actually matter to us as opposed to all the infrastructure underneath it. When we look inside of this, the base OS image actually has basically a full copy of the registry and more or less a full copy of Windows. Right? Why does it have a full copy of that? That seems kind of odd. It has that so that every machine worldwide that pulls a container will have exactly the same thing. Right? Exactly the same configuration. Why is that important? So that my applications run exactly the same way every time. If I didn't have that, my machine in my lab that's some Dell machine or whatever would have some Dell drivers on it. And someone else would have an HP machine with some HP drivers on it. And we'd be joined in different domains. We'd have different state associated with that. So our containers would run differently because of that, or might. Right? By having this clean baseline, everything runs the same. What we layer on top of that, inside of these application or these layers above it, is just the differences that are made. So in the case of something like a website, maybe I made a software, a reg key in software my key. That delta, just that delta is going to be stored there. And then whatever delta files are stored there. So any changes I made to the file system get stored in that image. Now the metadata for that image says, I depend on the application framework image called IIS. More importantly, I depend on the SHA hash of the image named IIS. This is the hash. Why the hash? Because I depend on the exact version of it. If tomorrow I made version 3.0 of it, I might have changed something that would conflict with those layers above it. We don't want that. We want it to be exactly the same every time. Right? Now, this also means we get a lot of efficiency out of container images. If I'm pulling the website down, that's a couple hundred meg at the most. Right? I've already got the base image somewhere. I don't have to recopy that down. I only need the application image. If I'm revving to a new version of it, I just pull that down. It's just the deltas. So I'm not having to copy around 20 gig VHDs with the entire copy of the OS anymore. I copy that OS instance basically one time, and then everything lives on top of it. They're just deltas. So how do we go about building an image? Well, the easiest way is to do it automated. And we do that through the Docker build syntax and a Docker file. A Docker file is a method for automating container builds. It's consumed by running Docker build. It caches unchanged commands and integrates into the Docker hub. So let's take an example. From Windows Server Core, starting from the Windows Server Core image, and then I'm running a PowerShell command to install the Windows Feature Web Server. This is how we build the IIS image, literally exactly how we build the IIS image, right? The result of that is a container image that we call Microsoft/IIS. Pretty straightforward. On top of that, I can now build a website. So taking that example, I would say from IIS or from Microsoft IIS, if one I was publishing, and I'm simply adding mysite.htm to inetpub mysite.htm. Literally just copy the file in, right? Now, if I ran Docker build on both of those, I would end up with 3 images. I'd have the base image, I would have IIS image, and I'd have my website image. right? If I wanted to change it, I just do Docker build again. It would rerun. Now, what do I actually do with these, or how do I get started with them? Well, that's where registries come in. Registries are a place that stores container images. Images are pushed into a registry, so we push them towards a registry. We can pull them back from a registry, or we can search for an image within the registry. Now, the best known one of these is the Docker Hub, also known as kind of the Docker Store as they're transitioning that over. This is a public registry. You can go to hub.docker.com. If you go to hub.docker.com/r/Microsoft, you'll end up right there. It's the Microsoft images. You can search for images within that. You can push images to that, make them available for anybody. You can also create private registries, similar to a GitHub model. You can have a private repo, right? You can do organizational. You can also do automated builds in the Docker Hub. What does an automated build mean? Well, I give that service my Docker file, and if an image below it changes, so like I said, from IIS, if we push a new IIS image, your image gets auto-built within the infrastructure of the Docker Hub, and you get a webhook that says, hey, there's a new version of your image. Do you want to test it? Do you want to put it in production? Do you want to just know about it? What do you want to do with it, right? We also have Docker trusted registries. These run on-premise. So we can actually run these locally in our environments, or we can run them in cloud environments, Azure, Amazon, Google, wherever you want. Gives you the ability to keep all of your images private for yourself, integrates into Active Directory, has some nice tooling around that. And if you want, you can go use the open source Docker registry, which is actually the foundation of the top two on that list. So this is an open source project, so go pull it down. It actually runs as a container image, of course, right? Why wouldn't you? So these are 3 different types of registries. And then Patrick's going to show us these in action.
All right. All right, thank you, Taylor. All right, so I'm going to go ahead and build a quick website here. So the image I'm going to be starting from is from this public repository here on Docker Hub, and it's just Microsoft/IIS. And this, if I go and look at the tags on here, of course, we can see the versions that are available. I'm going to use the one from yesterday, which is tagged as latest. So in order to get one of these, I can just simply do docker pull Microsoft/IIS, and then it will go ahead and pull the image. So since I've already pulled it, it says that, oh, it's already up to date with latest. So I'm good to go. So from this point, I could go ahead and run it. And then this is actually bringing up the container right now. And this particular one is actually based off of the Windows Server Core image, which I've already downloaded. So this is actually bringing up a server core, which means I could run it side by side with NanoServer. It's all based on the application I'm deploying and a particular container that I want to deploy. So I'll give that just a few more seconds to start up here, and then get ready to go look at the IP for it. Okay, so now the container is running. If I run ipconfig, we'll see I've got a unique IP for it, and I'll go ahead and connect and make sure that site is up and running. Okay, so the site's up and running. I can access it, and it was all deployed very, very quickly. And then if I do SC, well, I'm not in PowerShell. All right, so I'll just leave that at that. So if I go ahead and exit this container, it shuts down, and then this will eventually return the servers down. So now to actually build a container, I'm going to go ahead and use a Docker file. Since I already know that this image is a place that I want to start from, the first line of my Docker file is just from Microsoft/IIS. So that'll define the bottom layer underneath the container that I'm building. And then the next thing that I'm going to do from there is go ahead and just replace the logo for now. So I'm adding a file that's on my local machine, and it's going to copy it in the container at this location. And then so to actually run this, I would do docker build We give the container a name, and I'm going to prefix it with my Docker Hub username, so that way I can push it when I'm done. So I'll go ahead and say Docker build. We see it picked up this existing image right away. Now it's running the next step to copy these files into the container.
Patrick's poor laptop is just dying on multiple VMs running all these demos.
Yeah. Oh, the next one's good. I've got 3 VMs running in the background right now,
Yeah.
taking up all the memory I have. Okay, so now that's successfully built. Run. Now I can go ahead and run it. Give that a few more seconds to start there. Okay, so that's up and running. Get the IP address from it. Okay, now my modified site is up and running with our little robot there. Okay, so now the next step from there is, now that I've been able to build a container, I can go ahead and complete the cycle and actually go ahead and push that live onto Docker Hub. So right now it said that these other layers already exist. Because I was based off of the Windows Server core and then the IIS image there, it didn't need to recopy that data. So all it did was push that one tiny layer, and that completed right away. So if I go over here to my Docker Hub account and hit refresh, we'll see that that site I just pushed is now live right there on the site. So from here, I could easily go and deploy it on any server I want. All I would do is Docker pull and Docker run the new image. So,
Yep.
all right.
And if any of you want it, you can go do Docker pull Patrick Lang my site.
Yep.
And you too can have a robot IIS image. So this brings us into a fun section of the talk. So what about ... So these are a bunch of the questions that we've been getting over the last year and a half, 2 years, or at the booth. So the first one, this has been coming for a couple years. What about licensing? How are we licensing all of this? Well, there's a nice little PDF here, but the key core concepts is that if you're running a standard edition of Windows Server, you can run unlimited Windows Server containers on that. You are entitled to do that as part of your Server 2016 license. It's a pretty good deal. You get to run 2 Hyper-V containers, just like you could run 2 virtual machines before. You can do all the license stacking stuff that the licensing people talk about all the time. But if you're running data center, you can run unlimited Windows Server containers or unlimited Hyper-V containers. Right? I think these are a pretty good deal for most of us, right? This is a great way for us to take an environment where we were typically having to run a bunch of virtual machines in order to get the isolation and consolidation, and be able to swap that out for containers really without having to pay a whole lot more. So some pretty great terms. Really good one, how do I do patching? How do I patch these images? What's the story around that? There's really 2 ways to do it. And I'm going to spend the most time on the way that we think is the right way to do it, and that is updating the container OS image. Right? So this pulls an updated base image from the Docker Hub, and then you rebuild your containers on top of it using Docker files. How does this work? So let's assume that I'm starting from 10.0.14.393, and it turns out the GA build is .204. I didn't actually know what it was going to be when I built this slide, and I didn't update it in time. So .204 is what we're referring to as the GA build. So I start from that. I've got my website deployed. I'm happy. I got my robot. OK, KB blah, 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 blah comes out. It's Tuesday. What happens? Well, we push a new image to the Docker Hub, 10.0.14.393.1, right? Or whatever the right revision number is for that KB article. Right? Now, we're not really pushing the whole image to the Docker Hub. What we're really doing is we're pushing a delta. We're pushing just that top layer. Because we're using our own container images technology to do updates. But from all effects, it looks like a new image is there. So then we run our Docker file to build IIS. So we say from Microsoft Windows Server Core, PowerShell, install the role. We've got a new IIS image, right? Same thing for website layer. We run the same Docker file, and we rebuild the website. So why go through all this? Why is this the way that I will stand on stage and say, please, please, please do it this way? Because this gets us into the right DevOps model, right? We break people with patches more often than we'd like to, right? It happens. Sorry, I apologize, it happens. Devs break things too. Operations teams break things too. But if we have good tests in place, we can catch those early on. And if we get into the same process for everything, no matter what, we run the same test, because ultimately what I care about is that the website works on the top, right? I want to make sure I get robot guy when I go to that web page. If I use that same process, whether I'm changing the OS layer, whether I'm changing the application layer, whether I'm changing the configuration layer, if I run the same test every time, I get the same result, right? And so it doesn't matter where that change is occurring, I'm running through the same process, right? The other value in this is that I keep a nice clean stack all the time. Now if someone needs, if I'm gonna provision a brand new server, I'm pulling down 3 images, right? Let's contrast this with the other model that we have. And if you wanna use this one, you can happily go about using it. We built it for people to use, but we think the other way has got some advantages. So we do this one by making the update as a new layer. So what does that look like? So we've got our 10.0.14.393. We've got our IS. We keep the same image. We keep the same IIS image. We keep the same web image, right? Everything's the same. Then we run a new command on top to make a new layer. We basically run Windows Update inside the container. And what happens is it downloads the update, and once it's done downloading it, when the container stops the next time, offline, it applies it as a new layer. So you now have a new layer on top, right? And you can start your container up and continue to run. And you ultimately will end up in the same state as you did previously from a functional standpoint. But now tomorrow when KB 1, 2, 3, 4, 5, 7 comes out, you're gonna have a new layer on top of that, a new layer on top of that, a new layer on top of that. You're just gonna keep adding layers on top of it. Now when someone comes along and they say, hey, I've got a new version of the website, I built robot guy in green instead of blue, you've got to either go build that website off of the old image and then apply it all the way up to the top, or you have to now revert back to the other model, right? So now you've got a difference in model no matter what, right? Where we contrast with the previous example of just building up the same way every time. That's why I advocate for the other model so heavily, is that it keeps you in the same process no matter what. And this is all about getting into reproducibility and getting the advantages that come along with that, as we talked about early on. Right? So that's patching. So what about resource controls? Well, yeah, of course. We can do CPU. We can set a % cap of the host, so we can say, this container shall not use more than 10% of this host. When we use Hyper-V containers, we can even say, this container gets 2 virtual processors or 4 virtual processors or however many we want, right? But most often it's, hey, keep this guy at 10%, right? I know that person tends to write a little bit sketchy code. I want to keep them capped, right? Memory is even a better example of this. So I demoed in Mike Neal's keynote a Server 2012 machine that had been patched up and running for a while. And over the course of the week, that machine went from like 3 gigs to 3.5 to like 4 by the time I got to the demo. Why? Well, there's a memory leak somewhere on there. I don't know where, but somewhere there was a memory leak in some process. So if I set a cap on memory, I can make sure that that container doesn't use more than it's supposed to, right? Someone has some bad code, we'll cap them up. Right? We can set disk capacities. This is actually one of the things that we can do that Linux containers can't. Yeah. We can set a maximum I/O bandwidth, and we can set a maximum IOPS bandwidth. We pulled forward our Hyper-V container storage QoS functionality, and we brought that into containers, so we can set those kind of caps on them. Right? We also have platform support for network egress, and we're working with the Docker community to get that integrated into a future version of the Docker lib network driver. If you've got ideas about that or want to contribute on that, feel free to ping me, and I'll point you at the conversation about it. But the core message here is that we've got resource controls for all the major resource types. So what about networking? Everybody's favorite topic. Our networking stack is fully manageable through Docker, including network creation, enumeration, service discovery. We've been working hard to add all of these things into the Docker management stack. Docker has a notion of plugins that allow us to really integrate these things well into the Docker ecosystem. We've really done a lot of work to try to optimize this for the Microsoft Cloud Stack. So runs great in Azure, will run great in Azure Stack, runs great on Server 2016 environments. So that includes things like being able to set some advanced network policies, ACLs, quality of service through things like the Azure network layer. And soon we'll be able to do network load balancing through the software load balancer as well. That's some work that we're working on. Networking is an area that we're going to be working a lot on over the next couple months and potentially year as an area of continuous innovation. We've got a lot that we want to do in this space. Some of it we've already been doing. So we've done work for Docker tooling for Compose. We've got some limited support for that in the platform at GA. We're going to continue to work on that. Integration with other orchestrators, including Kubernetes and Swarm. We've got some work that we're doing around that. A big one of that is native overlay. Now, overlay, what that allows us to do is to connect two containers on different hosts completely transparently. Pretty neat stuff, right? We're doing work on that. And to be able to achieve some of the developer stories around having multiple networks and kind of making that story a lot easier for developers. So this is an area that we've got a lot of innovation we're doing on. Would love feedback on other parts of the networking stack that you find either challenging or have thoughts around. The other big one is, what about storage? Well, thinking back on our container image, the container image is not designed for persistent data. Why? Because as Patrick showed, each time you start a new container up, you get a new copy of the scratch space. So if you put your database there and you turn the container off, bye-bye, database is gone, right? It's also not really a good place for secrets. Why? Because if Patrick had put the secret to his container image to his environment in that container image and said Docker push, and pushed it up to Docker Hub, guess who's got the secrets now? Anybody who's got access to that image, right? It's a fun thing to do on GitHub if you're ever bored on a Friday night, just go looking for people's private keys. You'll find them. Same thing with container images, right? So not a great place for storing those pieces of information. What is a good place for storing them? Well, volumes. I put this in quotes because volumes in Linux and volumes in Windows are kind of different things. We think of volumes in Windows as C:, D:, E:. Volumes in Linux are a little bit different. They can be any mount point. And so as part of kind of unifying the management space, we're using the term volumes. In the Windows world, think of that as like folder substitution. We kind of called it shared folders internally for a while. Think of it as that. What it does is it enables us to have a persistent storage model. We can do read-only and we can do read-write. We can have multiple containers accessing that same location at the same time. And there's a notion of a plugin architecture. And then lastly, we can do network storage. So this is the obvious one. Container from an SMB share can talk out. Let's double-click on volumes for just a minute, though, because I think this is worth understanding at a deeper level. So we've got our container host, and we've got a container running on it, right? On the container host, we've got a C drive, and we've got a D drive. Sake of argument, right? And that D drive's got a folder in there called container data. Now, as Patrick showed earlier, when we look at the container contents itself, it's got Windows and program files and whatever stuff's in there. When we start up this container, in this example, we're going to say -v to say volume mapping, and we're going to give it some information. I want to map D: container data into C: data in the container. So what does the container see when it starts up? Well, it sees this extra folder called data. That folder is directly mapped to the host. Anything I write in that folder shows up in D: container data on the host. Anything that was in D: container data on the host shows up in that container. When that container stops and goes away, all the changes it made to container data stay there, right? This is how we do databases. This is how we put a SQL server inside of a container. We push the database file, the log file, out onto some persistent storage, right? Now when I want to change the version of SQL, I want to try a new version of SQL, I just start up a new container, point it to the same place, import the database and transaction files, and away we go, right? Pretty cool stuff. And we've got some great partners that are actually showing some of the volume mapping capabilities. So NetApp and Nimble both have demos here showcasing some of this work. There are a couple other partners, Flocker that's starting to try to do some of this work as well, and a number of others that are paying attention to it. If you've got a favorite storage provider, whoever that is, talk to them. We're probably talking to them as well. There's a pretty good ecosystem of people looking at and doing work with these volume drivers. What the volume drivers really allow us to do is to take data from like a volume on a SAN or a LUN and map it directly to a host, and then all the way into the container all in one fail swoop. Right? Great integration across that. So what about Active Directory for containers?
All right.
Really want a clicker.
Yeah, I need to be able to advance the slide. So how many of you like to deploy your databases using hard-coded passwords? Anybody? Is that your preference? No, not mine either. I had to do that for a while, and it was absolutely terrible. I had a vendor that wouldn't even let me change it. I'm not going to mention them by name. I'm not running their software anymore. When we start talking to people that are developing enterprise apps, one of the first things that they tend to ask is, how can I securely connect my application to my data backend? And the natural answer on Windows is, well, you can use Active Directory. Set up service accounts, use Windows Integrated Authentication, and then it just works. You don't have to provide a username. You don't have to provide a password. So we used the concept of group managed service accounts to actually go ahead and provide a way to authenticate a container to other services on the network. And so what we do is, rather than actually baking a username and password in, or doing a full domain join and then waiting 15 minutes for it to sync and replicate and things like that, instead what we do is we ask you to provision a group managed service account. It's something that your people are already used to using to represent applications today. And then we'll just go ahead and let you assign that to a container as you start it up. So when I have an application running in the container as network service or local system, which is typical when I'm installing a service, instead of it getting a machine identity like it would if it's domain joined, it will just assume the identity of that group managed service account. So that means that I don't have to make any changes to what's inside the container if I want to move it to a different Active Directory domain, even a different forest, because that's not stored in the container. Instead, I go ahead and provide it at runtime. So let me go ahead and show you how this actually works here. Okay, so right now I've got this, got my little laptop running 3 different VMs. And so for this demo, I needed to have a domain controller running, and then I also have a Windows Server 2016 host. This is running the build that was just released yesterday, as well as a SQL server that's running SQL Server 2016. And all these machines are currently joined to the domain. If I go and look at the SQL server, since my app isn't up and running yet, I can see that I have a database already created. This is going to be using the ASP.NET Music Store app, and then I can look at the list of logins down here. But since it's not running yet, it's not terribly interesting. So over here on my container host, I actually have all the files that are needed for this website already built, and they're in this container build folder. And the one I want to actually call out in here is, if I look at my configuration, I'm actually using a connection string that is just referring to my SQL server by name. That means I can go ahead and reuse the same SQL server or same SQL server cluster that I already have deployed, and then go ahead and use integrated security. So I don't need to have anything hard-coded in there at all. So first I'm going to go ahead and launch it. So when I launch this, I'm still using the same command I used before, docker run, but we've passed in basically a new set of security options that let you basically say, here's where to get the credentials from. If I actually click on the right VM, I can see that I've already provisioned these files on there. And if I look at the contents of one of these, it doesn't contain a set of username and passwords. All it does is have the SID and the information that's needed to identify that group managed service account on the Active Directory domain. So since my host is domain joined, I'm able to say these hosts are allowed to use these service accounts, which means I can go ahead and delegate those down to the container as I start it. So if I actually copy the command this time and run the container, right now this is starting up a Windows Server container, and it's going to be using this group managed service account called Demo SQL account. So I'll give that a few seconds to start up. I'm just going to get this other window ready for the next step. And then the other thing I did was, because this is a separate host and I wanted to expose it to my users, I mapped port 81 to it, so that way my users can access the service. And right now it's currently pinging itself, and that's working. So if I want to actually get to the website, if I go to the IP of the host, port 81, I see that my application's up and running. I've got the music store running. I can go shop through here. This is all up and running, and that's fine. But let's look at how it actually connected to the SQL server. So using the stored proc over here to look at all the logged in accounts, if I go and look closely here, I see that administrator's logged in. That's me logged into the actual SQL machine here to run a SSMS. But then I see that the container is actually logged in as the Demo SQL account. So it didn't take the container any extra time to start up. It just started the same way, just as quickly as a container normally would. And just to show that the container is completely independent of the account, I'm going to launch the exact same image here, but I'm going to pass it a different credential spec. And so this one has a different user account. So I'll give this in a few seconds to warm up here. And this one is going to be running on a different port on the host, which should be 80. Yeah, OK. So this one's running on port 80. So right now it should be making its database connection. If I go and check, let's see if it's connected. OK. So now I see that I've got the same container image deployed twice, but it's using two different service accounts behind the scenes. So I've got both the Demo SQL account and I've got the music store account up and running. And then if I go to port 80, which is just get to the other container, then also I still have the store running, completely separate instance, and I can go ahead and use the app just the same way I normally would. So that means that I only have to write and package up my application once, and then I can move it from each environment, dev, pre-production, production, just by changing the credentials that it's going to be running under. And if I wanted to change other things like the database name or whatever, I could also pass those in as environment variables. So it gives you a new layer of agility without sacrificing any security. And it's all based on the technology that's already there in group managed service accounts since Windows Server 2012. So just to recap what I did there, the first thing that I had was that I had configured an image to run the website using just the standard default accounts, local system and network service. And then I provisioned the host ahead of time to be able to use this service account. I created it on the domain. I registered that account on the host so it could access it. And then when I launched the container, that would actually allowed it to go ahead and access the SQL server using that shared service account that I'd already provisioned on my domain. So it's very similar to what you would do outside of a container, but I still retain all the benefits of the containers, and I can start them up extremely quickly compared to provisioning a whole new VM, domain joining it, redoing all the ACLs and all of that. So it keeps containers fast and consistent. So do you want to go on that?
Sure.
Okay.
So a lot of you saw earlier demo from Aqua doing some security and auditing work. There's really 3 partners that are all doing work with Windows containers around secure deployment, auditing, being able to ensure images are trustworthy, and provide audit logs. So Aqua is certainly one of them. Twistlock is another, and then within Docker, we have some great tools as well. So really 3 different choices. Anytime there's different choices, I always recommend to people try a couple of them out. Look at what works best for your environment. The best part is that the more people who are looking at it, the more competition there is, the more options there are going to be. So 3 different ways to kind of look at that. So automation and management. This is always an interesting topic for us. What do we do for automation and management? Well, to really get into this, the first thing you need to understand is that there's a notion of composition and orchestration. When we think about applications, they're typically comprised of multiple containers. Right? We may start out by just moving a website over, but that website's talking to something else. It's talking to a database. It's talking to a middle tier. It's talking to a web service. And as we start to build those into containers as well, what orchestration allows us to do is to tie them together. So I can now say the web server talks to the database server. Right? The web container talks to the database container. And I can do that in a meaningful way, in an intent-based manner. I can say that this is the connection I require. What it also allows us to do is to host containers across multiple nodes. So we can now point the containers at a set of nodes, a cluster, a swarm of hosts, and say, make my containers run there, and here's some rules to run by. Like, please don't put all of the web servers on the same node. Right? That doesn't do much for my high availability story if someone accidentally unplugs the server and all of the web servers were running on there. It doesn't matter that I had 4 front ends, they're all dead. Like, please make sure they're spread out. And that's what orchestration tooling really does. When we look at that, there's a couple different options. So Docker's broken this up into 2 pieces, Compose and Swarm. What Compose does is the orchestration piece of it. Compose is what allows us to define the relationship between our containers. So in the example on the screen here, we've got a web container. We've told it how to build that container. We've said its Docker file is in the web directory. We've told it some information about the network, like it wants port 80, right? And then we've told it something about a database container. This is where to build it, and that it's on the default network. Now, when we actually want to start that container, that application up, we can just say Docker compose up, and if it has the containers already built, it'll start them. If it doesn't, it can build them. And we start talking about our containers as an application. We stop talking about individual containers. We start talking about an application. Now, what Swarm does is it aggregates a set of hosts together. So it says, all right, I got 10 VMs. I've got 10 hosts. Treat them as one big Docker engine. Right? And so I can actually issue all of my Docker commands against the Swarm endpoint. I can say Docker info. I can say Docker run against that endpoint. And Swarm goes, all right, I know how to spread that out. I know how to say run a container here, run the next one over there, run that one over here. It knows how to aggregate all that together, so it makes for one massive container host. Right? And it supports notions such as tagging and anti-affinity and affinity and the things you generally expect to see out of clustering type technology. Right? Another option around this is Azure Service Fabric. Now, there's some confusion around this as people are going, well, wait a minute, I heard Service Fabric, I thought I had to rewrite my whole app to use that. Service Fabric is a microservice and orchestration platform. It's a little of both. So if you're looking at the microservice level of that, yeah, for building a microservice, you need to build it using the Service Fabric APIs. You've got to build it using that construct. But as an orchestration platform, it has to know how to put stuff in different places. That's part of being a microservice platform. Well, we taught it how to put containers places too, right? So you can build applications as containers and or microservices and use Service Fabric. The important part there is or microservices, so you can either build a microservice application or you can use containers for it. It's now available on Windows and Linux. It's kind of nice. It has some built-in cross-container communication capabilities. We kind of refer to this as service discovery or naming services. Has a web-based UI. You can see a screenshot of it here. Available on-prem in Azure or in other clouds. And as part of Server 2016, you already got access to it. It's part of your Server 2016 license. It's licensed to Server 2016 customers, even Server 2012 customers, I believe. Right? Another option, Kubernetes. This is an open source project that was kind of kicked off by Google. Brendan Burns, who was the original architect of this at Google, now works for Microsoft. He's in the Azure team. And Windows support has been being added by the community, actually spearheaded by one of our partners, Aprinda. They saw the value in using Kubernetes for orchestrating their environment. So as part of that, they went off and did some of the work to get that kicked off in the community. And at this point, it's actually working. We've seen good demos working of Kubernetes. And if you want to get involved in that, you can get into the Kubernetes community. They're looking for people to both help in terms of actual code, if you want to get your hands dirty on that, as well as understanding what do people need out of containers in that environment. And then there's also Mesosphere Marathon. So this work has been ongoing for about a year now. There's still a decent amount of work going forward on that. But again, it's a way of aggregating container hosts together, building an application that's comprised of those, and then executing against that application. Right? So we've gone through, we talked about Compose and Swarm, that's option number 1. We talked about Service Fabric, option number 2. We talked about Kubernetes, 3. Mesosphere and Marathon, that's 4. I can almost promise you by the end of the year there will be a 5th or a 6th orchestration engine out there. They're springing up like crazy. My advice to anyone is go look at a couple of them. The reality is they're all running Docker containers at the end of the day anyway, so the ability to move between them is not too difficult. Right? Most of them have tools to transform between the different environments, because at the end of the day, the metadata that they have isn't all that different. So try a couple of them out, see which one works best in your environment, see which one you think is best, and keep your eye on it, on the other ones, because as they change, you may find that one of them adapts some technology that's really key for you, and you can just switch over. To that, in the Azure Container Service, we actually support currently 2 different orchestrators. We support Swarm, and we've got DCOS. Now, as I mentioned earlier, Mesosphere DCOS not available for Windows yet. So what's available in the Azure Container Service for Windows? In private preview, we have Swarm support. If you want to get into the private preview, shoot me an email. We'll bug our friends over in the Azure team, and we'll get you looped in on that. This is GA for Linux, so if you're interested in running Linux containers, party on. Ultimately, what the Azure Container Service does, it stands up some VMs, and it gives you an endpoint that has either Swarm or DCOS configured on it. You tell us which one, we set that up for you. Where's the real magic come in for it? When you got a problem, you call 1-800-Microsoft Help Me, and we are able to help you with support and problems around it, right? That's really what I think the biggest magic of the Azure Container Service is the support element of it. Some other management monitoring tools. Docker Data Center. This is some cool stuff. What Docker Data Center is a kind of a really amalgamation of a couple tools. The Docker Trusted Registry and the Docker Universal Control Plane. Those, along with Docker Swarm, and the commercially supported Docker Engine, which anybody running Server 2016 has access to. And what this gives us is a really nice set of tools for looking at our containers. So we can go in, this is a screenshot of a dashboard. We can see all the applications, we can see the containers, we can see the images, we can see the nodes we're running on with a nice web-based UI. We can do things like RBAC controls. So I can say, yeah, the developers are allowed to run this many containers on our infrastructure. Operations team is this much. The CTO, view only. Don't ever let that guy change anything ever. But he's got to have view permissions or he gets mad, right? So you can have some of those controls run it. If you go to the Docker booth here, they'll be happy, I'm sure, to give you a great demo of Docker Data Center and look at it. Or you can go run it in Azure. We have an Azure image for it. You can go give it a try in Azure today as well. We've also been working on tooling within Microsoft Operations Management Suite for monitoring containers, monitoring Docker. I actually think this is a really great complement to Docker Data Center. If I was running in production, I would actually run both. Why? Because what Operations Manager does is it monitors an entire environment very holistically. So not only am I looking at my containers at that point, I'm looking at the hosts, I'm looking at the network, I'm looking at the storage, I'm looking at the entire environment. So if something has a problem, I can root cause that much quicker than if I'm looking at a macro piece of it. Docker Data Center is going to do a great job of giving you a nice view on the containers and the applications. But if there's a network switch problem, it doesn't really know a whole lot about that other than I can't talk to the nodes. Operations Management Suite does understand that and can give you a nice view on, hey, that switch has been giving you errors. And that's probably why the application down here is giving us errors too, right? And give you root cause analysis back to it. So what about some development tools? Steve's going to talk about this, or I guess Glenn actually on Friday. We've been doing a bunch of work within Visual Studio to make the tooling around this much easier. You've seen Visual Studio Code a few times with IntelliSense support, so it can build Docker files and that kind of stuff. We've also been doing work within full Visual Studio to have F5 debugging, the ability to just right-click on an app and say, yep, make that a container, and do all of the kind of work behind the scenes to make that possible. This already works with Linux containers today. Windows Server and Nano Server are coming really soon. If you go harass the guys in the Visual Studio booth, they can give you more details on it. But this is a great way to kind of get started and get some of that full experience around it. So as we're kind of wrapping up here, of course, I just want to mention, please do evaluations for us. 5s are preferred. Unless it's the scale of 10, then 10s are preferred. Whatever the highest number is.
11.
Back. So why does it keep doing that?
Auto advanced.
It's auto advancing.
Yeah.
So as as we started off the morning or the session, really this was the second step of our journey through containers this week. So we heard about them in the keynote, got excited about them there. Hopefully today we've gone through kind of what are containers, how do they work at the architectural level. We've given you some tools around that. Thursday morning, 9 o'clock, we're going to go into some of the Docker pieces a little more deeply, some of the lessons that we've learned out of that. Thursday afternoon, we're going to work with Tyco. We're going to talk about how they've actually built their app, how they actually did the work to move their application over and what's the next steps for them. And then we're going to talk about how you can start taking applications and moving them over to containers as well. And then Friday, to kind of wrap up, we're going to talk more about the Visual Studio tooling around containers and how some of that's evolving. And then hopefully by the time you get back on Monday, you're all rested up and you're ready to start bringing an app over to containers. And with that, we've got a couple minutes for questions even. So there's a couple mics back there. If you've got questions, please do use the mic so we can pick them up.
So you spent some time talking about how containers can authenticate using Active Directory accounts with SQL Server, et cetera. Can incoming clients also be authenticated? For example, IIS-hosted Windows authentication. If you set up a domain account, will that authentication and authorization work?
Yeah, so I don't have a sample to share on that yet, but my expectation is that it should. So
That was
we're
the
working
design,
on it. And if there's various things that aren't working, please let us know, because we want to continue to do more to make it easier to secure applications and containers.
All right.
So.
Hey there, you showed multiple web servers running on different ports on the host machine.
Yeah.
Does Docker containers have any built-in mechanism to do content switching between those, or do you have to set something up in IIS or Apache?
Yeah, so you could put whatever load balancer you want in front of it. In my particular case, I didn't have a load balancer set up, but you could use IIS application request routing. You could put whatever service you want in front of that to do the switching there. In my case, I just had a basic NAT network, and I just mapped those two through, but you could do more sophisticated routing as well.
Thank you.
And
problem.
as I mentioned on the networking slide, we are planning to build our software load balancer into the stack over the next couple releases as well.
Hey, on the patch management section, in the tech previews, you had to have the Windows Server host at the same patch level as all the containers. You didn't mention anything about that there. Is that no longer required?
So as we're now moving forward, so the hard requirement, the architected requirement is that the major build number, so 14393, whatever that is, has to be the same for Windows Server containers to work on the same host. Hyper-V containers don't have that limitation, but that means that an update, like if we do an update tomorrow, let's call it 10B, the update for next month, those containers should still work. From a support standpoint, we want them to be the same, but they will work within the major family. Yep.
Okay.
On the same patching theme, does the switch to the new cumulative update on a monthly basis change any of your recommendations? I mean, you could just have one layer that's just updated per month for updates then, correct?
Yeah, I mean, so the cumulative update actually helps make this a lot easier because every month when we push out an update, it'll be cumulative. So you'll just be swapping out that layer. I still think that patching from the bottom up makes the most sense because you are still going to end up with multiple layers on the top over time because you'll end up going from January to February to March to April. And so if you end up having to change something below it, now you're still having to reapply. Even if you just applied that top one that last time, you still have to kind of build back up, and you have a harder time getting that reproducibility out of it.
But won't April include January?
The patches do include that, but you have a harder time kind of understanding where along that patch line did something change or break. So I still am a big advocate for starting at the bottom and building back up again.
Do you have support for nested virtualization in terms of Hyper-V on ESX?
Do we have support for nested virtualization, Hyper-V on ESX? So part of that is a statement that I can't make because I'm not from VMware. Our commitment is that through the software virtualization validation program, that we would support anybody who supports us. So they support us, then we'll support them, and vice versa. I happen to know it works in most cases. I don't know how well or what the performance trade-offs are. But we do have Hyper-V on Hyper-V for people who are interested.
You talked about the SQL files being stored onto the container host, which can be mapped onto the container. Is there a way I can map them, assuming that I want to protect this data, the container data, and I want to map this SQL files or this modified files to this container?
If you want to map the files from container to container?
Container, the files which are on the container host to this container.
That's what a volume will do for you, yep. That's exactly what a volume
I mean,
is.
do you provide APIs or is there something like that?
Yep, -V on the Docker command line will give you that volume mapping.
Okay, it's a command line API.
Yep,
Yeah.
yeah.
Thanks.
Just a quick one, it's maybe more of a Docker question, but the Docker data center, the UCP, and the trust repository, can you use that to one of those to manage both Windows and Linux, or do they have to be separate?
So I'm looking at my Docker friends here. I believe the answer to that will be yes. Not wanting to put words in their mouth.
Yes to being separate, or yes, it will work?
Yes to be the same. Yeah, I'm getting a nod. So the Docker engine APIs are the same between Windows and Linux.
Okay.
Because the Docker engine is actually the same. It's just cross-compiled, right? It's part of we've been working in the Docker open source.
Cool, thank you.
So when it comes to the networking piece and SDN specifically, and you have multiple, I think there are NSGs in the Hyper-V speak or endpoint groups in the Cisco speak, how do you handle that with a networking piece?
That is a great question. Jason Messer is our networking PM. He's here, and he'll be around at the booth. I would like to double check with him on exactly how he would answer that.
Okay, thanks.
From the licensing perspective, you were saying that we have the possibility to put all the containers that we want on the servers, but what happened with the things that we put inside the container? So imagine that we have a SQL server.
Yeah.
That means that if we expand 10 containers, it will consume 10 licenses.
So licensing of the applications inside, so even from a Microsoft lens, we're still thinking about how are we going to license things like SQL and that kind of stuff inside of containers. And the ecosystem is really starting to think about that as well. So today I don't have a great answer other than for the developer edition, party on, we're still thinking about it. Obviously we want to make sure that we get paid for our licenses, but we also want to make sure that customers get value out of them. So we're thinking about it quite a bit. If you've got thoughts on what you think a good way to do that, please let me know. I can pass that feedback along to the team who's thinking about it in SQL land. And certainly other applications are thinking about it too.
Okay, thank you.
Got time for one more question, and then I'll be around afterward if there's other ones too.
Well, I have a feeling this is a real dark question, so it won't be a quick one. Okay. So with with the Hyper-V containers, is there any reason you'd be deploying Windows Server in a regular Hyper-V VM anymore with Windows Server 2016? Because it seems like the Hyper-V container gives you everything you need with complete isolation and...
Well, I mean, so we're trying to get to this point as well. We'd like to just put Hyper-V or put a Windows Server on the metal and run Hyper-V containers on top of it and not have to use VMs at all. That's going to give you the best performance characteristics.
Yeah.
Where VMs become still valuable is that a lot of people, and we're one of them, in Azure, we know how to deploy VMs. We don't know how to deploy these container things yet on our Fabric. We have to teach the Fabric how to do that still. And so for our own sanity, what we're doing right now is we're deploying a VM, we're deploying a container inside of it, even if we're running the Hyper-V container inside of it.
Right.
But our goal, our aspiration is to remove that layer of virtualization and just run in bare metal. All right.
All right.
We'll be around for questions afterward, either here or we'll be at the booth the rest of the week. Hope to see everybody on Thursday as well, and thank you for your time.
All right, thank you.